Hello, in this video we'll be going over another basic motion problem. So this question has been taken from the Queensland curriculum from the Oxford Study Buddy for Physics Unit 4, Volume 1. This is a Unit 3 question, and I'd say it's about B level, I reckon. Alright, let's get straight into it. So this is question 27. A rubber stopper is being while in a horizontal circle with a radius of 1.2 meters, and it has a distance of h above the distance of 2 meters above the floor h. The stopper completes 10 revolutions in a time of 8 seconds. The string breaks at the point X and the stopper falls to the ground as shown by the dotted line. So we have a ball that's going around like this, and it's getting cut here and then it's falling down like that. So that's what we have to picture. Determine the time it takes for the stopper to fall to the floor after the string breaks. So this is a motion question with circular motion and a projectile. So recall, let's just take a look at this circle up here. We know that we want to find the velocity at which it's been released, because it's only going to have horizontal velocity. We're going to assume it's going completely flat. So recall that velocity is distance over time. This is traveling in a circle. So the distance this ball is traveling at the top here is the circumference of the circle. So circumference is 2 pi over the radius. So velocity is 2 pi over time. The radius is 1.2 meters. The time, it completes 10 revolutions, so the distance it travels in 8 seconds is this distance here times 10. So to work out our velocity, we just need to plug in, so velocity is 2 pi r, so r is radius, which is 1.2 meters. I'm just going to leave the units off for now. And it completes 10 revolutions in 8 seconds, so if you just put 8 as the t without the 10, you'd get that wrong, because it's going around here 10 times in 8 seconds. So that's why we need to do the distance times 10, and the time is 8 seconds. So plugging that into your calculator, you'll get a velocity of approximately 9.42 meters per second. Now we actually haven't answered the first bit of the question yet, but we're going to need that bit for the just the understanding. So once this has gone around here, its velocity at this point, once it gets cut, has a horizontal velocity. So u of x is 9.42 meters per second. So it's been cut here, and this is 2 meters high, and this is d. It's been cut here. It's got a velocity of that, and it's going to travel like that. Right? So to work out the time it takes to hit the ground, we have to look at the vertical motion to find its time. So the vertical motion, the initial velocity in the vertical direction, or the y direction, is 0. Is 0 meters per second, because it's only being projected horizontally out of the circle. It's only going like that way. It's got no angle to it. Right? Hopefully you understand that. Acceleration, g, is gravity, negative 9.8 meters per second, and the height, s of y, is 2 meters, and we have to have a negative sign because our initial velocity in the y direction is negative, so it's negative 2 meters. So using this equation here, s equals ut plus a half at squared. You can also write like s of y equals a half gt squared plus uyt. That's another way you can write it. Plugging those in, negative 2 equals negative 4.9 t squared plus 0 times t. So where I got the negative 4.9, that's a half times negative 9.8. That's where I got the negative 4.9 from. Alright, this term over here goes to 0. Divide by negative 4.9 to get t squared over there, and then you square root it. So T is approximately, using your calculator, you'll get 0.638 seconds. Okay? Alright, so that's part A of this question. So it asks for 2 decimal places, so you go 0.64 seconds, and you'll get your mark. Alright, cool. I'm just gonna get rid of this stuff now, here. So part B is to find the impact velocity. So the impact velocity is the velocity at the point at which it hits the floor. Since there's no acceleration in the horizontal direction, u of x is the same as v of x, so the initial horizontal velocity is the same as the final horizontal velocity, which is, whoops, wait, oh, I don't know what's happened there, which is 9.42 meters per second. Now here, at this point up here, u of y is 0 meters per second. But since gravity is pulling it down, you're going to have a velocity vector in this direction slowly increase. So we're going to have a pretty big vector at this point here. So to find that, we need this equation here. V squared equals u squared plus 2as. So v squared of y is the same as, is equal to u squared of y plus 2asy. Alright, so v squared of y is v of y is the square root of 0 squared plus 2 times negative 9.8 times negative 2. Putting that into your calculator, you should get a final velocity in the vertical direction as 6.2 meters per second. Now I'm going to put a negative sign in front because the velocity is going downwards, so it's negative 6.2 meters per second. So the sign doesn't indicate anything other than direction if it's velocity. Alright, now that we've got that, I'm just going to rub this out. So we're not done the question yet. Now we've got to draw a vector. So at the point, we got to find this velocity here. So we have horizontal and vertical velocity. So we know this is 6.26 meters per second, and we know this here is 9.42 meters per second. So we know that a squared plus b squared is c squared. Therefore, v is the square root of 9.42 all squared plus 6.26 all squared, square rooted. Using our calculator, that should be equal to approximately 11.31 meters per second. Alright, then you gotta find the angle in here. So opposite, adjacent, tan theta is opposite over adjacent, so theta equals tan inverse of 6.26 over 9.42, and that is approximately 33.6 degrees. Alright, so you gotta put your answer 1 decimal place, so 11.3 meters per second at 33.6 degrees to the horizontal. And boom, you get 2 marks. Alright, now we've got that out the way, I'm just going to rub this out. And the last part C is pretty simple. It's basically asking what's the distance the ball or the rubber thing travels once it's been released horizontally. So it's basically just asking for this distance here, where it lands, how far it lands from where it's been cut. So that is just s of x equals u of x times t. We worked out the time is 0.64 seconds, and u of x is 9.42 meters per second. Right, so s of x is 9.42 times 0.64. So s of x is our distance, d, is approximately, using your calculator, 6.01 meters. Once it's at 2 decimal places, so 6.01 meters is fine, and you'll get your mark. Alright, hopefully you understood this question. I'd say this is about a B level question because of this stuff up here. if you got confused with this here, that is basically probably where students would lose their marks. They would get follow-through marks because they would get some random velocity here and hopefully do the rest of it correct, but getting this velocity and thinking about it was probably the hardest part of this question. Alright, thank you so much for watching. If you want any more videos like this, just leave some in the comments. I will be posting more motion questions. This one was a projectile and circular motion question. I'll be doing some others in the future. Alright, thank you.